Hello, everyone. Thank you very much for joining us. We're just gonna wait a couple of seconds till everyone joins. Okay, let's start. Good morning, everyone, and welcome to today's Solarabic webinar. Personally, I'm very excited to hear from both my dear friends Malak and Edgar because it's a very new and trendy topic. Today's session, titled From Manual to Robotic PV Installation, a Technical and Economic Comparison, is something that is everybody is talking about right now. Robotic PV installation is still a new conversional in our region, but I truly believe that it has a real potential to change the game in how utility scale operation and even the C&I, the huge C&I project, how they are being developed and executed and operated. Before to start in the topic, I just want to invite my colleagues and my dear friends Malak and Edgar to introduce themselves to our audience. We can start with Edgar.
Good morning and good afternoon for everyone. First, thank you, Solarabek, for organizing this webinar, and thank you for Lipting for inviting us to be there. I'm very happy also and excited to be here. I remember very much that since almost 3 years when I joined Jinko, I had my first webinar. It was with Solarabek, and it also included Malak and Amira. So I'm very happy to be here with you both. Discussing those new topics here.
Thank you very much. And we are very excited for this webinar, actually. Malak?
Hi, good morning and good afternoon, everyone. Thank you for joining us. This is Malak Rai from Lipting. Thank you, Solarabik, for organizing this webinar. Thank you, Jinko, for joining us, actually. This is extremely exciting topic to discuss and to speak about. So, looking forward to the webinar with you.
Thank you very much, Malak. Actually, yes, and thank you for Leapting for sponsoring this webinar and discussing this topic, not only in this webinar and also in the white paper that we recently published with Leapting. Where we discuss the technology of installing using robot PV installation, and we covered the technical and the economical and the practical aspects of this solution. After we published the white paper, there was a lot of interest in the market. We received many questions and many professionals reached out to ask about the solution, and they had established that literally this solution can benefit them a lot. So today's session is a continuation of this discussion, and we will move from the white paper to a live conversation with experts who really can explain the solution clearly and help us understand the real value for solar project execution. And we will cover all the parts of it, how it affects the panel, and who better than Jinko Solar to talk about how this solution is compatible with their panels or the panel and how it can affect the whole project development. I will not take longer time than this, but before moving to the discussions, I want to welcome everybody, all the attendees, and I want to invite them to ask and to answer the poll question that will appear at the screen right now in front of them. Our attendees who watch us in Facebook, YouTube, and LinkedIn, Instagram, you can answer at the comment. From what country are you watching us? We will give it just a few seconds. 15% from Saudi Arabia, another like 13% from UAE, Bahrain, Oman, Qatar, Kuwait, 6% from Jordan, 8% from Syria, Lebanon, Iraq, and like we have 8% from Egypt, 9% from Libya and Tunis. Like we have like from all over the countries, and we have also like a lot others. So welcome to everybody, and we're very happy to have you. Now I'm very happy to start today's session with our dear friend and excellent industry professional, Edgar Abul Khair, Technical Service Manager for MENA region at Jinko Solar. Edgar, the floor is yours.
Thank you, Amira, for the introduction. Is my screen visible? Can you see my screen? Great. So thank you again, everyone, for joining us. We are happy to be here today to start with you recommendations or some highlights that we would like to share with you. First, for us as a PV manufacturer, for installation and handling of PV modules, and then share with you the importance of having some tests in the field and how we can comply with the new technologies that we are seeing using automatic cleaners and even automatic installers, robots for PV panels. So I'll start first my presentation with a just small introduction about the company, and then we will dig more deeply into the installation and handling recommendation from Jinko Solar. So first, as an introduction, Jinko Solar is one of the biggest companies worldwide in PV modules and solar cells manufacturing. We are celebrating this year our 20th anniversary with a huge milestone, which we have broken this year with a 400 gigawatt of total global shipments of PV modules. And we are the only company globally to reach this milestone with 7 years #1 in the global shipments. And we see as much as we are growing in the industry, as much as we are seeing demand for solar panels, at the same time, the capacity and the production capabilities of all the suppliers is growing. And at the same time, we see that for all the suppliers, whenever the capacity is increasing, at the same time, during manufacturing, the automation is very important. And it's already more than 98% of the manufacturing lines are automated. So now we will see also that not only the manufacturing lines are being automated, we see that in new projects, also the automation is being adopted during the installation. So this is a very important topic to speak about today, how with the growth of the market, we can adopt new techniques for the installation of the PV panels and for having less risks with them. So in terms of research and development, we can see that Jinko Solar holds 32 world records in terms of cell efficiency. We have more than 2,000 people working in the R&D stage, always providing us with the new technologies, with the new improvements. So our latest achievements in terms of cell efficiency for the N-type TOPCon, the most mainstream technology now in the market, is 27.79%. And in parallel, we are also working on future technologies that will be introduced to the markets in a couple of years, which we have also holding some world records with them, which is the tandem technology with 34.76% as a technology. We see also that we have introduced at the beginning of 2026 our newest model called the Tiger Neo 3.0. Now, my main presentation will not be focused on it, but just a small introduction about this product, which is the advanced TOPCon technology introduced in this product. It will have a maximum power of 670 watt with a maximum efficiency of 24.8%. We will be introducing a lot of improvements in the datasheet parameters of the panels. The first one is the temperature coefficient, where it's being decreased from 0.29% per degree Celsius to 0.26, so that the panel can be performing better under higher temperature conditions, especially in the desert. Also, we have an advanced bifacial factor improved to 85%, so that the panels can be having an improved generation, especially from the backside. This panel is being designed based on the mainstream dimensions in the market. So the area is not getting bigger. We are using the same area of the panel, but we are improving its power and its parameter, which is also easier for us to have compatibility with either cleaners, robotic cleaners, installers, and also trackers. We have also an optimized annual degradation of 0.35% instead of 0.4%, so that through the lifetime of the project, the panels can generate better energy. Also, in terms of shading behavior, those panels are designed in a better anti-shading behavior, so that we will have additional 8.3% more power compared to traditional panels in the market. And finally, those panels are also designed to have a better low light performance, so that whenever the radiation of the sun is lower, blocked by either dusty environments or any overcast, this panel can generate higher power, can reach 8% compared to other technologies in the market. So this was just a small introduction about the company, about our newest product. Now going through also, since the market is getting a lot diversified and we see some special requirements for specific projects. So at the same time, we have introduced the new products that can be applicable for special applications. The first one is the offshore solution, where the panels are designed with a better improved bill of material so that they can withstand the harsh conditions of any coastal application or any offshore application. We have also customized panels for dusty locations called anti-dust solution, which they can be having modification in the frame. And at the same time, we have the option of providing a steel frame, which can be stronger for the panels, especially in the desert conditions. And those panels are equipped with a self-cleaning coating that will be able to decrease the amount of accumulation of dust on the panels, and it will also be decreasing the amount of operation and maintenance, and especially the cleaning cycles. We have also extreme weather modules with a thicker glass that can achieve fire class A with a stronger mechanical loads. If you have any project with high wind or high mechanical loads, it can withstand them. And also it can achieve a higher hail impact. And finally, we have the anti-glare solution, which is designed mainly with a special coating on the glass, or special glass that is used for locations near the airports that can reduce the amount of glare from the panels. So this is regarding our special scenario modules. Now going to the main purpose or the main objective of our presentation of today, we will give you some recommendations from us as suppliers on how to install the panels, how to handle them, especially during the installation phase. But starting first with the options of installation or mounting structures that we might have in our projects. First, we will have the fixed tilt structure, which is the most common option used in most of the projects, especially in the C&I section, where the panels are installed on purlins that are fixed and mounted to the ground or to the rooftop. Also, we have a second option, which is the tracker option, which is a moving structure that includes motors, and the panels will be rotating so that they will be following the sun. For the tracker options, we have two distribution. The first one is called 1P, where there will be one row of panel installed on every tracker, while the 2P solution includes two panels or two rows of panels that are installed on this tracker, as you see it here in the picture. So usually every type of mounting structure should be compatible with our panels, either included in our installation manual or by doing compatibility test report validated by third parties, so that we can confirm that the panel is compatible with the type of structure that's being used, and at the same time it can handle the maximum mechanical loads that could happen on site. Specifically for trackers, any module with the same dimensions, with the same distribution, should be compatible with this tracker, so that we can confirm that can be safely used together and safely installed. And at the same time, we have a track record with many tracker suppliers, which we have compatibility results with them. So going to the panel, how it's being mounted to this structure, either if it's fixed structure or if it's tracker structure, we mainly have two options. The first option is the clamping solution. So usually the clamping solution is by using clamps. As you see here in the figures, you see we have two types of clamps. We have the mid clamp, which is used to install two adjacent modules and fix them together through the frame. And the second one is the end clamp, which you see it here, is the one used at the end of every row. So first, those clamps should be designed, should be having dimensions which are compliant with our requirements, and at the same time, they should have enough place to be able to be fitted or to be fixed on the frames of the modules. And it's not recommended to install those clamps randomly on the panels. We have in our installation manuals a lot of methods that can be used for the location of the clamps, where you should exactly locate your clamps, and at the same time, the number of clamps that should be used for the panel, so that the panel can be safely fixed to the structure and avoiding to have any issues with the panels, and to be able to handle all the wind loads that could happen on site, and at the same time, if there is any snow loads in your location. So this is the first solution for mounting the panel. The second solution is called by using screws or bolts. So the panels during the manufacturing stage, they come with a frame, and in this frame, we will be having mounting holes that are already drilled during the manufacturing process. So usually the mainstream modules in the market, they include 12 mounting holes. You see here in this drawing, you see we have 6 on this side and 6 on this side. And we see that we will give you the exact distance between every mounting hole, so that in case you are using them for fixing the panel on the structure, you will be using them in the correct way, and you can include them in your design. And we see here a section view of the frame of the panel, where we have the screw, which is located on the mounting holes. So usually it's not advisable to drill additional holes on site, because this will incur maybe some issues within the solar cells or within the panel. So this is why we can provide you with those mounting holes to use them and to install them. And usually, most of the time, we see that we have operators using either the clamping solution or the screw solution. It all depends on the design of the structure that you are using and how much you are willing to pay for the structure or to pay for the mounting that you are using. And also, this will also have need some time to be installed, especially if you are using manual operators. So this is why in the next session with my colleague Malak, she will introduce to you some solutions for either handling the panels or installing the panels, and this will make your installation more efficient and more quick, especially in future projects. So then we noticed based on our experience in the market that many people, they are not well experienced, or maybe they are using the panels in a violent way and not as per the recommendation. And this could cause a lot of problems. So some of the problems that we noticed in the market, people standing on the panel. As you see here in this picture, there is one operator he was standing on the panel to be able to do some modifications on the side, which panels are not accessible. In this case, we highly recommend not standing on the panels. It's totally forbidden to stand or walk on the panels. Even the frames, it's not advisable to walk on them, because on both cases, you will have pressure on the panel, and we will talk about more details, what are the main risks that could happen due to standing on the panel. The second thing that we noticed on site is that how the people are handling the panel. So you see here that some people, they are handling the panel and one person is only handling it. So in this case also, there will be a lot of risks of having cracks in the glass or cracks in the cells while some person is handling the panel. So it's always advisable for 2 people to handle one panel, so that we can avoid any deformation in the panel or any risks of glass breakage or micro cracks. And also, some projects, they include spare parts in their sites, so they store their spare parts randomly and they expose them directly to the sun and to the wind, to the rain. So with time, the damage will happen on the pallets, and it will also damage the panels. So please also make sure whenever you are storing panels on site, to store them either indoor or in locations where they are not directly exposed to either the sun or to the rain. So those are some things that we have noticed on site, and they will incur a lot of issues. One of the main issues that could happen in the panel, it's not the glass breakage as of the people think, but it's micro cracks. So micro cracks, they are cracks inside the solar cell that are not visible to the naked eye. We cannot see them in the naked eye. And the only thing that we can do, or the only test that we can do to notice if there is any micro crack in the modules, is the electroluminance test. So this is one of the most important tests that we can do. This is not a destructive test for the modules. It's only for characterization technique, so that we can be able to see the module in a way where we cannot see it in the naked eye. And the main concept of the test is by using special high sensitivity camera, which can capture more than 1000 nanometer wavelength. And this camera, it will do something like we compare it to the medical X-ray for human bones. So to go to the main concept of the photovoltaic effect, so the cells, whenever they are exposed to the sunlight or to the irradiation, they will convert those photons or those irradiation to electricity. And we have noticed that this effect, called the photovoltaic effect, can be reversed. So in the dark, when there's no irradiation, if we inject current to those cells, they will be generating light. And this light, we are able to capture it by using high sensitivity camera. And this is how the AL test or electroluminance test is being done. In the dark, we can expose the panel. We inject to the panel a DC current, and when those cells, they will emit light, we can capture it through this camera. And we see here an example of a picture that is showing the result of the electroluminance test. It will show you exactly if there are any defects in the solar cells, specifically micro cracks that cannot be noticed in the naked eye. So usually this test is either done indoor in the lab or during manufacturing, because we will need a dark room, or some new technologies, they are using drones. They can do them also for big scale projects, but it should be done in the dark during the night, or by separating some modules and putting them in a closed and dark environmental chamber. So why we are talking about specifically this test? Because whenever we are doing any compatibility for the panels, either with some automatic cleaners or automatic installers that we are using now in new projects, it's very important to do such tests before using the robot and after using the robot, so that we can confirm that there will not be any cracks or any defects in the cells, that we cannot see them in the naked eye. And here I will give you an example of stepping on the modules. We can see here in the picture on the left, someone that stepped on the module. And by the naked eye, you cannot see any breakage either on the glass or in the cells. So this is why if we take this panel and we do for it the electroluminance test indoor, we can see that by doing this test, you will see that the cells are now broken. And those micro cracks will lead to a lot of risks in the future, like bad performance in the panel. And if it will remain for a long time, it will have a hotspot on the cells. You can see here also a zoomed out picture of the panel showing where the micro cracks happened. Also, I would like to share with you a video which was published by NREL that's also simulating the main risks of micro cracks and how they could happen mainly to the panels when we are doing electroluminance tests. So you see that the solar cells, they are very thin. It's 120 micrometers, so it's very easy to be broken. So you see here, this is electroluminance test. We do it for a panel, and we see that some people, they are stepping on the module or having pressure on the module. And you will notice that whenever this person is walking on the panel, you see that the cells will be cracked. You see here, those are all micro cracks on the cells of the PV module. So this is all, as I said, it's not visible to the naked eye. It's something that's invisible, and it will affect the performance and the reliability of the PV panels. And here I would like to conclude my presentation with some reference list of our main projects in the region. So you see that we are having gigawatt scale projects that are all using manual installation. And this is where it's important now that since the market it's evolving, it's getting bigger. So we need to search for new solutions, for more efficient solutions, for handling the panels, for installing the panels. And those solutions should be validated by us. And at the same time, they should be proven to be efficient in terms of making the project in a very fast way and finalizing the project in a more efficient way. And at the same time, with having less risks for the PV modules and avoiding having any issues with the PV modules. So that was all from my side. And thank you so much for your listening.
Thank you very much, Edgar, for this insightful presentation. Actually, I have one quick follow-up question. Like you talked about the EL imaging test, how many times does Jinko Solar perform this type of tests on module at the manufacturing process?
Yes, so it's a very nice question, honestly, Amira. Now, because of our extensive quality control criteria in the manufacturing process, we have many steps where we do this test during the production phase. So during first the cell production phase, before the solar cells are taken to the assembly stage, we will do for them electroluminance test so that we make sure that every solar cell alone will not have any breakage, and before assembling it in the module. We also do this test the second time before doing lamination. So it's the step where all the solar cells are connected together and we have on them the encapsulant and the glass. So we do the electroluminance test also at this stage. And at this stage is also we can replace cells in case they have any breakage. We can do some fixing at this stage. And then the third time we do it is after the lamination, when the encapsulant, the glass, the frames, they are all laminated together. We do also the electroluminance test to make sure that everything is good and they abide by the criteria. And finally, after curing, before packaging the panels, we do this test at the final stage to confirm that the panels won't have any micro cracks or any bad soldering issues. And those EL images, they are all available for our clients so that they are part of our FAT test and they can be provided for any client for any specific order.
Thank you very much, Edgar. Before we move next to Malak, we really would like to know more about the professional background for our audience. So we will have a very quick poll that you will have it in front of you at Zoom. From what is your industry? For all of our attendees who watch us live on Facebook, YouTube, LinkedIn, and Instagram, please feel free to leave your answers at the comment section. Okay, 9% are from developers, 25% are from EPCs, 12% consultants, and we have around 10% from the public sector and the rest from the other industries. Thank you for everybody, and we're very happy to have you. Now we will move next to my dear friend Malak, who will introduce to you the presentation about the solution and will also discuss the white paper.
Thank you, Amira, for the kind introduction. So I'll not repeat myself. Thank you everyone for joining. Just Amira adding a very quick, let's say, comment. You know, usually in this industry or in these webinars, myself, I have sat through a lot of these webinars. Almost every session is about the technology. Cell efficiency, bifaciality, temperature coefficients, let's say, degradation rates, etc. And all of these are important. We're not saying it's not important. But what Edgar just covered is something that is rarely gets into its own dedicated session, let's say, in such a webinar. So about what is actually happening in the site, how the module is being touched, moved, clamped, and whether anyone bothers to check actually what they did, if it actually hurt the cell structure or no. So that part of the value chain that gets minimum attention comparing to the other. And it is where a lot of damage happens in the site, silently, invisibly, and where people cannot see it with the visible eye. Where you can only see it, let's say, if you run the EL test. So timing here is the best to provide today's session and to speak about the automation. Because what I am going to show you and discuss again is the installation side of that. The same question can be answered about what does it look like when you remove the human variability from the process of the installation. So let me take you through the presentation. So starting with this context, because about MENA solar market, because the scale of what is happening in this region is what makes this conversation really urgent, and that should happen actually. So as you know, just very quickly, the MENA solar market is really moving at a pace where most of people in this room or in this meeting is actually understanding this very well. 100 gigawatts of projects capacity are planned to be done by 2030, 2029, 2030. Multi-gigawatt tenders are being awarded. For example, let's look at Saudi Arabia, UAE, Egypt. Annually, we are working on gigawatt projects. So the financing is there, the land is there, the policy and the plan is there, but there is a gap that does not get talked about enough in these sessions. The gap between how fast these projects are being awarded and how fast they can actually being built. So the installation phase alone can consume up to 20% of the project of the total project capex. This is from a commercial side. From timeline like side, it can be stretched to 18 months or even more. And we're speaking about these utility projects. So the opportunity is massive. The projects are there, but the bottleneck here, if we can call it this way, is on the ground. It's about the installation part. So let me be more specific about what the challenges actually look like in these projects in practice. So 5 things, if I can call them, are working against manual installation right now. And they are not going away like this. No, it's there. So we need to find a small or any small contribution we will do, it will make a huge impact. So firstly, we have the cost for sure. Installation labor usually accounts for up to, as we mentioned earlier, 20% of the total capex. And that number does not shrink or getting minimum as the project gets larger. No, it will be stay the same or even higher. Secondly, we have the speed. We have the problem of the time. Okay, we have the money, we can spend the money on the labors, but we have another problem, which is the time. Manually crews or manual manpower averagely per team install 200 to 300 modules a day. We are speaking about good practices with safe installation. And this ceiling is tied up directly of how many people you can put in each site and each team and how hard you can push them. Because at the end of the day, we are human. We are not like a machine. We will have a limit of work. Then we have the third challenge, which is safety. Safety in 2 formats. One of them is the large module formats. Now the market has modules above the 700 watts, which physically demanding like a good handling and demands high power to handle them from the pallet to the table. And here where the problem came is some people will do cut on the manpower. So you will have the risk of hurting the module and more important, hurting or injury the people who are working inside. So you will have the risk of having more degradation, having more damage in the site. Number 4, we have the heat. This is the other point of safety. For example, looking at GCC or the whole MENA region. In GCC, regulations prohibited the outdoor working during peak midday hours from mid of June, let's say, or from June, early June, until mid-September, around that month. And that is roughly around 200 working hours per season. Like gone, like this way. We are losing 200 working hours or even more. And if you are aware of any such regulation in your country, please write it to us in the chat. I'd love to know about that. So we are speaking about money, we are speaking about time, we are speaking about safety, and module-wise and people-wise as well. Then number 5, we have the quality of work. Alignment and placement consistency depends entirely on the crew experience, fatigue levels, and another thing, the time of the installation. For example, if we are doing installation in the site with a flexible timeline, people will be happy while they are doing installation. But if they are being pushed we cannot control how they handle the modules. Maybe they will throw it, they will do it fast. So this is maybe harming the modules. The solution for these parts is not better training program. It's not larger crew. Part of the solution is moving the variable entirely to a robot or to a systematic solution. So this is LeapTank MMR, the module mounting robot. And I want to connect it directly to something Edgar showed us earlier. He had that slide about the violent operation where one person dragging a panel, module being stepped on, spare parts are lifted exposed on the ground. And his solution was to have like 2 people per panel, protective tools, proper palletizing, let's say. That is the right answer for manual installation. Looking at the other solution we are providing is the MMR, where it takes a different approach entirely. It handles the module mechanically with a controlled arm that can reach up to 3.1 meters. More technicalities, I'll speak about them in the next slide. But mainly, we are even using a specific solution. We love to call it diamond-oriented rotation, which is our rotator, a specific movement machine, let's say, designed to minimize the mechanical stress on the panel while we are moving and rotating the panels. No human fatigue is there, no improvisation, no one person shortcut from the 2 people should handle the modules. The modules go from the pallet to the rotator to the robot arm to the table every time the same way at the same rack. So let me give you like just a quick overview while we have this video running. The robot arm can reach up to 3.1 meters, which can handle, that means 2P or 2 modules in portrait alignment or 4L. The capacity of the arm, it can take up to 210 kgs, which means basically our modules, no matter how large it is, it will be safe to handle it. It will not fall down. That means, in other words, it can handle Jinko's Tiger Neo 3, 3.0 at 670 watt, the one we mentioned earlier, and even beyond these sizes without any issues. Installation rate, we are speaking about 25 minutes per pallet, which has 36 modules for sure, including the loading time to the robot. And you can see the rest numbers. One more important thing we always like, two actually important things we love to highlight as well. It can operate in a temperature range between minus 20 degrees up to 65 degrees. That means we can hold the harsh environments that we have in Middle East. And how the robot is being fed from power side, we have a battery. This battery can be fed from any other source. It can be fed from the grid, from the tables in the site, from a diesel generator. Like mostly we are compatible with most of the feeding sources to the robot, which gave us more, let's say, flexibility on running the robot inside. And for sure, since we mentioned the module sizes, just one last thing. The larger module gets, and Edgar, you can correct me on this, the different alignment of the module we will have. So the normal sizes of the module, we receive it in our horizontal alignment. The larger modules, we receive it in vertical alignment to the size to the site during to the size. And both sizes or both alignments we are able to deal with it, regardless if it is vertical or horizontal. So mentioning these things, every time we sit down with a project owner or EPC and we start talking about these robots, the same 5 questions will come up. Can it keep up with the manual crew? Will the cost really be saving because this is a machine? And we will not need only one in the site. We will need more than one. Does it fit our existing racking and the trackers? Does it fit the existed solutions we have in the site? And what happens when something goes wrong? Does the robot stop working at the site suddenly? And this one always comes up question, especially after a session like the one Edgar just ran. What does the robot like actually do to the module, because you are loading, you are handling the module, you are moving while doing the installation. Earlier, what we saw in the presentation, we show exactly what stepping damages looks like under the EL imaging, something we cannot see in our naked eyes. Those micro cracks are invisible to our direct looking. So they do not show on the visual inspection where people do this usually. But they are there actually, and they degrade the performance over time. So the question is fair. This specifically, all these questions are like make sense all the time, but specifically the number five, really important to have it. Does automation introduce the same kind of these hidden risks? Are we going like to harm the module in any ways? And we are going to answer this with the field data, not only with the tests that are happening in the site. So before addressing these questions, just adding one safety point firstly about again the working times, because it's not only we are caring about the modules harming, we are caring about also people who are working under the sun. As we mentioned earlier, it's either you will compromise having people to work under the sun, and that might have a problem, and it will cause them some, not some actually, a lot of problems, or you will compromise 200 working hours from the site. So here is where MMR can help actually. It will support people, it will support the modules as well. So let's have this very quick comparison side by side between manual installation and the MMR or the robotic installation. Manual installation usually will have 200 to 300 modules per day, inconsistent due to the human nature. It will be crew dependent, limited by heat and fatigue, and the alignment quality might vary from time to time. That will cause doing the rework again. On the other hand, you have the robotic installation, around 600 modules per day, reliable AI-driven placement, let's say tools, or I would love to call it intelligence installation tool, that will result in 1 millimeter misalignment, because the robot is not working on pre-mapping. No, the robot is actually sent to the site, will have some learning time, some learning period, and based on that, based on this AI intelligence that is integrated with the robot, it will work accordingly based on the site conditions, based on what is installed in front of this robot. That's how we will result in this 1 millimeter misalignment rate. And we are even actually targeting more. So inshallah, in the next webinar, you will have a better even number. Operating across different temperature ranges, as we mentioned earlier, from our past experience, cost reduction is approximately 30% of the labor cost. And this varies from one project to another, depends on the case, depending on the timeline, how fast you want to do the installation. Labors usually drops from large crew to one operator with the robot and two people to do the fastening and one person to do the alignment. Power shifts from, like, as I mentioned earlier, diesel generator to like it's not fed directly by diesel generator. It can be charged by diesel generator or by the grid or by the table even directly. So the gap is real and it's consistent. It's happening. But we are seeing a solution. We are seeing improvements in the life of projects right now. So numbers are one thing, technicalities are one thing, but let me show you how this actually looks like in actually running projects. So this is one of my first, I hope that the video is working. This is our first deployment globally for MMR. I want to highlight it, which is in Australia. We have a 20 megawatt project, and one of the global benchmark cases for intelligent PV installation. Part of it, which is over than 10,000 modules, were installed using MMR. installation efficiency, it was 3 to 5 times higher than the manual labor. Zero module damage, zero manual, zero personal, sorry, damages or injuries. And part of that, that was the first project that around the globe had the first robotic installation. Then we have our second case, which is, let me run the video. Okay. There is our project in Middle East. We have, which is the deployment that matters most of this audience since we are in Middle East or MEA region. Under PIF4 projects, lifting was deployed on large utility scale in GCC under extreme desert conditions. Edgar showed earlier some references from GCC projects. You will see more, inshallah, with installation. These environments where manual crews are most constrained, let's see. Heat regulations, fatigue, large format of the modules. All of these require like 2 people to handle safely. And our results as lifting in PIF4 was 20% cost saving, 25 minutes per pallet, which is a really good track record for the installation, and zero human injuries across the entire deployment. And the MMR run through the heat that stops the module, like that stops the manual from working. Actually, it was even some of the robots were deployed in August in the في عز الحر at the peak of the summer because the handling was controlled, consistent, not depending on tired people. This was the result of the installation. So zooming out, just to have a look of our deployment around the globe, 2025 was the inflection point for lifting globally and for the whole installation robotic industry, let's say. First Australian order was in February for lifting, and that was the first deployment around the globe. And we started after that coming to the Middle East, to Peru, to other countries, Australia, Spain, South Africa. We are coming, or the automation is coming around the globe. What is really important to mention about all of these projects, EL testing was conducted on site for these projects. Not all of them, based on the requirement of each one. But EL testing was conducted not in factory, not in lab, but in the field on installed modules using MMR. The same EL imaging technique that Edgar described earlier, using the DC current, the high sensitivity camera, looking exactly at the kind of hidden cells cracks which were not there, alhamdulillah. No, even no surface scratches because of the robot. And actually, part of these projects were using Jinko panels, and the results were zero effect from the robot on these modules. So, and I would love to share it with anyone who can reach out to me who's interested to read these reports or to learn more about them. Feel free to reach out to me by email or even by my phone number. I'd be happy to share these results with you because many points and many discussions goes around this point. Many questions. Are we hurting the modules or no? And the answer is no, basically. So before we close, I would like to give you a bit context about who is behind these solutions, who is leading, because the technology is only as credible as the organization behind that one. So lifting, in a very quick words, lifting technology is a high-tech company focused entirely on intelligent automation, not only providing cleaning robots or whatever. No, we are providing intelligent solutions robots for the solar PV field. We are focusing on AI. Our main vision is to automate as much as possible from the solar power plants operations. A quick look on our solutions. We have spoke about our module mounting robot to be launched soon. Actually, it's being deployed to a project, but to be launched officially soon. We have our automated forklift to support the MMR. It is also using the same technology of self-driving and AI mapping, etc. We have it also to be deployed. Then we have our, I'd love to call it, we call it the second generation of cleaning, but myself, I call it the tractor cleaning robot, which is, if just very quickly, you look at the past and the history of cleaning robots, how it started. Part of that, you have normal tractors. Some smart people started this where they connected a brush to the robot and they started to do the cleaning. And this is extremely smart, actually. What lifting providing is something similar, but self-driving. No need for manpower to drive that. Then we have our very mature solution, the cleaning robot, where usually people ask me if we have cleaning robots. Yes, we provide cleaning robots as well, the very mature solution, and it's commercialized over, actually this number should be updated, 17 gigawatts around the globe. Looking at the history of the company, just very important point. We have started 2022, but you can see us in gigawatt scale projects around the globe, more than 17 gigawatts for cleaning and more than 3 gigawatts for installation. This is the announced ones. So mentioning robotics, it is very important to look about, because robotics is very complicated component in the site. So whenever you are speaking to a robotic company, you should ask about one very important point, which is the support. So looking at the support we have at LeapTech, we have, let's call it 24/7 support. You can find our offices in US. We have our main factory and offices in China. We have also our service center in India, Singapore, Australia, and very recently we have our after-sales support or O&M office in UAE, and we are opening, it's undergoing in Saudi Arabia as well, and coming to more countries, inshallah, for the support for both cleaning and installation robotics. So just let's bring it back to where we started. Edgar Jenko walked us through what the modules needs from the installation process. Proper handling, no stepping, no stress on the cell, EL imaging from time to time to verify that nothing went wrong. From after that, moving to what will happen to the module during installation, during the loading, then moving, or how we are moving from the manual installation, basically with MMR. The answer is always the same. Automation will always give you a controlled and consistent, mechanically precise placement for the modules, verified technically by the on-site EL testing that results with 0 micro cracks across all the field deployments. So this is the standards that we are meeting. And if you want to see in action or have a dedicated session about how we will address or how we are doing this installation, I'd love to be in touch with you. And yeah, this is it. Looking forward to have your questions.
Thank you very much, Malak. And I'm very happy that, like, all the very insightful topics that you mentioned. And yes, it is something that it's really new at the market, and it really matters the most right now, where like we can see the prices of the panels has decreased, or sometimes we see that it will increase in the next future. But when you really want to control the financing of the project, you can't control some of the parts, which is for the equipment, but you can, if you use a smart solution, you really can make a difference. Malak talked about the white paper. We shared it at the links. You can download it, and you will really find all of the value that really matter to you. Just take a quick look at it and you will understand how much this is a game changer. And also, I would like invite everybody, if you are visiting SNCC, you can meet with the LeapTech team at, you can see the booth and the hall in front of you. So feel free to reach out to them, contact them, sit down with them and ask them all the questions that you would like to ask them. Now, Malak, I want just to give you 1 minute to take a rest, and I want to start with Edgar with the questions. We have like a lot of questions to everybody, and I'm super excited with the community and the discussions in all of the platforms. But I will start with Edgar with a question are asking about on what basis are the EL imagining assisted? Are there any specific criteria for it?
Yes, for sure, there are specific criteria for imaging for the production phase where the most important defects could happen on the cell during the production phase. So this is why we have included in our quality assurance plan to have a specific criteria for each type of defect or each type of thing that we could inspect on the cell. And there will be included with this criteria a passing percentage and a rejection percentage. And based on this criteria, also that can be shared with clients and mutually agreed based on their requirements, on which basis we can accept the image or not.
Okay. Thank you very much, Edgar. My next question is to Malak from Artsam. He asked, are you already calculated the cost of manpower and robots, which is expensive, or any consideration?
Yes, actually, this is a very good question because when we propose a new solution, you should look at two things: finance and technical. So finance-wise, every time we sit with the client, we will do these calculations, and every time we will have savings. For my point of view, even if it was the same cost, it will be technically more reliable. But even though there is always saving on the manpower, this is actually the catching point about robotics. So yes, there is saving, depends on the project. Averagely, we are speaking about in most of our projects, we are speaking about something between 25 to 30% of saving on the manpower. You can calculate it on the percentage weight of the capex from the overall projects as well.
Okay, building on that, Carl asked, why only 600 modules? Are 600 minimum, or
Yes.
can he expect more?
Actually, you can expect more. Would love to have a session to speak about that. It depends on the site condition. It depends on the tracker type. It depends on how the robot will like how much information you will feed us, and the robot can build on that on the site. Actually, yesterday internally we were discussing the next target for installation. So within the next quarter, you can expect even much faster installation. But it's all like if we're speaking about 30 seconds per module, this is quite fast, but we are targeting even more.
Okay. Thank you, Malak. Going next to Edgar, we have a question like, are the special scenario products using Tiger Neo 3 technology, and are they available in mass production?
Yes, thank you, Amira, for the question. Yes, all the scenario-based product that we talked about, like the offshore, the anti-dust, the steel frame, the anti-glare, and the special application module, the triple advantage module, they are all available, implemented with the Agni 3 advanced technology, and they can be available for order.
Okay, perfect. Thank you very much. We have another question, like somebody wants to have a quotation for 1 megawatt on grid from Jinko Solar. You can leave your contact, or even you can contact Edgar. We left Edgar's contact information, and he can link you to the sales who can give you the quotation that you need. We have another question for Malak. Would you classify solar robotics adoption as an early stage experimentation or already proven in the bankable utility scale projects?
Actually, no, we can consider it as a proven technology because If we were speaking about the first project we had last year, we can say it's experiment, even though it wasn't, because before deploying any robot to the market, we will be testing that for years in the factory. So it is a proven. Even the what we are having now running ongoing projects, you can find us in PV3 in Abu Dhabi. You can find us in BIF series of projects in Saudi Arabia. And yeah, even regarding, I just want to add another point regarding the earlier question about the 600 modules. In peak times with good practices in Saudi Arabia, because we had a very collaborative client, let's say, and some days we were even achieving 720 modules per day installation. This is because, so it's directly affected by the idle time. The less idle time you have, the more productive or productivity you will have. And this deployment came to more projects. So it's bankable, it's there, it's not experimental at all. It's already in the market.
Actually, this is very impressive. Moving next to the next question is that does the robot only install the panels and tightens the panel to tracker with nuts and bolts?
Not yet. It's not a no, but not yet. It should be coming soon, the automation, but so far the robot is placing the modules on the table only. Then you will need, as I mentioned earlier, two crews to do the fastening and alignment if needed.
Okay, actually, we have like million question about the robots. Like everybody is very curious to know more. In real utility scale project, where does lifting actually create measurable value today? OpEx reduction, yield improvement, or labor substation?
Such a nice question. The answer is basic everywhere. So lifting vision is to be in every step in the project. Firstly, our target is to start before in early stages during the installation time, where you will do the saving using the MMR. Then after that, and this is will effectively do reduction of the cost on the capex part. Then after that, our vision is to be in the operation of the site from day 1 to year 30 inshallah. So how we are reduction the OpEx part, the OpEx is being reduced by deploying the cleaning robots, by having a very good model of support from lifting on the ongoing projects. So the reduction is happening on both capex and OpEx cost.
How easy is it for EPCs and developers to integrate lifting into or the MMR into existing solar projects?
Um, Easy actually, because now we have the experience, we have the breakdown of the activities that are happening in the site, and based on that, we will have the discussion with the client, which activities he would like us or they would like us to cover, and based on that, it will be integrated very easily. Yeah.
Okay. We are at 3 minutes ahead of our time. I'm just gonna close with a final question. MMR robot only provide the module or they fix nuts also with the structure? I believe we covered this earlier. We mentioned like there is a let's say surprises that are coming in the way for lifting. And the final question is gonna be from Amin. At what capacity we can find a breakthrough in saving?
This is actually depending on many factors, but roughly I can speak about 30 megawatt myself, but it depends on the project. I'd love to have this discussion based on the project inputs. So that's why, yeah, thank you, Shada, for sharing my info. You can drop me a message and we can discuss the model together about the break even. Usually it will do saving, but depends on different factors, including the time of the installation.
Okay, perfect. Then one last question to Edgar. We have also a question from Artham. In night, the PV module still can generate DC current and any technologies, any new technologies for Jinko?
No, actually, the base of the cells are to generate based on the radiation. So since at night we don't have irradiation, then still the panels cannot generate. There are no technologies yet in the market that are proven to generate electricity in the night. We hope that it might be happening one day, but until now, no, the only thing that could be done is to upgrade with batteries so that you can, whatever generation you are getting during the day, you can store it in batteries and use it during the night.
Thank you, Edgar, and thank you, Malak, for this very insightful session and the new topic. And we can see like how everybody is curious about it. I want to say, like personally, I learned a lot from hearing from both of you, and I'm sure that everybody also learned a lot. So thank you for everybody who attended, and thank you for Malak and Edgar. And we wish that everybody, like if you have any questions or you want to ask anything, the presentations, we will share it with you. You can download the white paper from the link that we shared with you, and you can contact Edgar and Malak easily. So again, thank you everybody, and I wish you have a good day.